Hey everyone, welcome back to ML Works. In this video, we'll be continuing with our LangGraph tutorial, and in the previous tutorial we were discussing how to build a bot with LangGraph, and we also added a tool to it, which is a search engine tool. Now we'll move on top of that and we'll add memory to the bot, and we'll also have a functionality for adding human in the loop while you are chatting. Okay. So the setup is similar. You just have to install the LangGraph package, which is pip install LangGraph, and once that is done, then we can start with our tutorial. So first what we have to do is we have to create a state graph, which is the structure for your chatbot. A state graph will have both nodes and edges, and nodes are nothing but where you perform the action. For instance, it could be an LLM call, or it could be a tool call, or it could be some other task or some kind of an action that will change the state of your chatbot. And then you will have edges. Edges are nothing but when you want to move from one node to other node, okay, you go through edges, and edges can be either direct edges or you can have conditional edges. Okay, so based on that you will be moving to certain nodes. Now, so for that, first we want to import all the packages that are required. Okay, so these are the 10 packages that you want to import. Okay, once that is done, we have to create the structure of the bot, which is done by state graph, and this is what it is called, state. First you have to create a class state and mention how you manage the messages between the bot and the user. Okay, so that is done here in this class, and then we build a state graph. So this is termed as graph builder. Now graph builder will take in all the nodes and edges. So once you are done with this, so let me first import all the packages. Let me run this, and then let me run the state graph. And next I want to import all the API keys. For instance, the LLM that we are using is Gemini 2.0 Flash. So for corresponding API key is imported, and there is a tool which is called Tavily search engine. Import corresponding API key for that. So both are imported into our runtime environment. Once that is done, we create our LLM here, initialize the LLM chat model. So this will load the model, LLM model. Now what we have done is we have loaded the model, but it has you can only directly chat with it. Okay, you can send the query, get the response, but it still doesn't have access to the tools. So what we do next is adding the tools to these LLMs with the help of bind tools. So first we are defining the tools. In this case we have two tools. One is the human interruption or human assistance, also called as human assistance. This is one tool, and the other tool is Tavily search, which is a search engine. So we build these two tools and we add them under the specific list. This is Tavily search and this is human assistance, and they are stored into a variable called tools. Now let me run this. So once this is run, okay, what we do is we bind the LLM with these tools. So what we do is LLM.bind tools. This is our Gemini model. We are binding it with the other tools. Next, what we do is here we create a bot as a function. So this function will be acting as a node. We have to add that node as to your graph. So what is this function is called as chatbot with multiple tools. It has access to human assistance. It has access to Tavily search. So all these chatbot will take the state of the current, what is the current state of the chatbot. It will take that as the input, and then whatever is the message, right, it takes that messages and it makes the call to the LLM. Let me run this. So one thing just I want to clarify again. So this function will represent only LLM, okay, the calls made to the LLM, okay, not to the tool calling or maybe even the human assistance, right? It won't go there. This is only for LLM. So we will get the response for LLM from here. So once you have created the function chatbot with multiple tools, you want to add this chatbot to the graph as a node. So what you do is, using graph builder that we created earlier, just to dot add node, and you are giving the name of the node as chatbot with multiple tools, and this is the function we are referring to. Here we are referring to this specific function. So we have added one node to the chatbot. Next, what we do is how to communicate or start the chatbot. So for that, what you have to do is you just have to add an edge and start command and move it to this specific node, because this is the node that we created here. So this will communicate the start command to the chatbot. Okay, this is the entry point, kind of an entry point. Now, since we added an edge, so we can look at the edges here, or we can also look at the nodes, okay, which is this one. So we have everything present inside of a graph builder. Now, till now what we have done is we just have a graph which with a LLM. Now we want to add the tools to this corresponding graph also. So for that, what you have to do is we can create a function class like basic tool node, which is capable of turning your tool into a node for the graph. So this will take in, you can have multiple tools, so you can iterate through the tools and create a dictionary here, and then you can make how the tool will manage the messages, right? So this is how you want to do this specific call, okay, call function. So here it will get the latest message from your chatbot that is happening, the chat that is happening, and then it will call the corresponding tools for that. Whatever the message is present, you will look at what are the tool calls that has to be made. Then you iterate through that tool calling, okay, and then make a tool call.invoke and call the specific tool. This is how you get the name of the tool, and this is how you invoke it. And whatever the input query or search query that you want to make, it will be passed as tool as an argument, and it will be stored as a tool result. And once you get the result, you will be storing it as part of outputs. Now finally you will get another dictionary at the end, which is messages as the key and outputs as your value. Now this is the class, and what we do is we use this class here and pass the tools. In this case it is human assistance, and then you have Tably search. Those two tools are there, and you will be creating a tool node. Once this tool node is there, we just want to add that node to the specific graph under the name multiple tools. So let me see if we have run the previous command. Yeah, so let us run this one. So is it executed? Yeah, so we have added a node to this multiple tool node to the graph. Okay, let me show that. Graph builder dot nodes. Now you will have two nodes. Okay, one is chat multiple tools, then you have node for multiple tools here. Now you want to decide which tools to select or route to. So for that we have to bring in add conditional edges. So this will decide to which tool it has to send. Okay, either it is an LLM or it has to send it to the tools that we created, either it is Tably search or human assistance and everything. So here based on this function that we create here, route multiple tools, it will takes the current state of the chatbot and it looks up the messages, state message and the messages inside the state. And if there is no message, then it will throw an value error. Otherwise you will make the call. If it is tool calls, then it has to make a tool calling, otherwise it has to end the conversation. So this is our route multiple tools, and this function gets used in this specific conditional edges. Now it will be, you will have chatbot with multiple tools, you will see the condition and then you will either go to this one or go to this one. Now this will be so one thing, right, if you see here, anytime a tool is called, if you are searching something, okay, and the next step should be it has to call the chatbot. It should not end the conversation, it has to call the chatbot. That's why what we do is we create an edge, multiple tools, then it will pass it to the chatbot. Now one more thing, right? So we were talking about human in the loop. So we have created human assistance function and using it as a tool. Now we've also talked about, we want to discuss how to manage memory in chatbot. So what we have to do is we have to initialize something called as in-memory saver. So it will create a memory object, and when you are trying to compile your graph, you want to enable this checkpointer and is equal to memory. So what it will do is it will checkpoint your conversation and it will store it in memory. Otherwise, if you don't want to do it in memory, you can also store it to some other database if required. For example, you can use Postgres as well. Now, so we have memory functionality. We add it here while doing the compilation step. So let me run this. So we have built our graph with tools, with memory functionality, with chatbot, with LLM and everything. Now let us just visualize the graph. So you will have start, and then you will make an LLM call. It will go to the chatbot, and then it will go to the multiple tools, which could be functionality like search engine or human assistance. Based on that, you will get the response and it will go back to the chatbot, and if it is satisfied, then it will move on to the end state. Once that is done, now let us make some calls here. So what we do here is we first send a prompt to the LLM that it has to raise a request for a human assistance. So we send a prompt where we say, I need an expert guidance for building an AI agent, and could you request an assistance for me? This is the user input that we are giving. Okay. So this is, we are sending it to an LLM, and LLM will understand the specific user input and it will ask for a human expert. So we are also sending something configurable thread underscore ID as one. This is in connection with memory. We'll understand that in some time. Okay, just remember that you have something called as configurable, which is with a thread ID has one. Now, events is equal to graph with human in loop dot stream. So if I go back here, you will see this is where we have our graph with human in loop once we have compiled it. So when we are once you have this graph, then you do dot stream, and whatever the input or user input you give, you pass it here in this specific format, and then you also add the configuration, which is this one, the thread ID, and then stream mode has values. Now this will make a call to your graph and give this as the input, user input or user query, and get a response from LLM, and we are just going to print that here. Okay, so this is the human message that we sent. Okay, and it went ahead and called LLM, and it modified this query into something, I need an expert guidance for building an AI agent. Now if you see here, okay, it is the state of the graph, the current state of the chatbot. In a sense, it is under multiple tools. It did not complete the conversation. Okay, it is in the multiple tools. Now it is waiting for some kind of an expert assistance. Now what you can do is, it has like kind of paused here. Now what you do is you give the human response, which will be taken as a command and with the key has data, and that will be sent to the graph. Now then what will happen is, if you just run this, so you will see here, this is the query that we had, which the AI generated, and this is the human assistance which we have given, which contains the specific solution for a certain problem. In this case, it is how to build an agent. So you are saying that you can use LangGraph to build an agent. Now the AI message, this human response is taken by the AI message, and that is an LLM, and it transforms this into a format such that the user can understand again, okay, which is the experts recommend using LangGraph to build your AI agent. They say it's more reliable and extensible than simple autonomous agents. So this is how the expert has given a suggestion, and the AI has given at the end as result to the user. Now this is how you would stop the conversation, take human input, and then continue the conversation. Now what we'll do is we'll test the memory aspect of chatbot. Now you have something called as user input, and you say something like, hi there, my name is Will. Now that is your user input, and that you send it to the your graph, okay, which is a graph.loop, right? Graph.stream. And if you remember, I showed you earlier what is config, which is the thread ID has 1. Now the stream mode is equal to values, and this is again we are printing it. Okay, so hi there, my name is Will, this is your user input, and the AI has understood your name and it is saying how can I help you today. Now what you do is, as you move forward the conversation, you ask the chatbot again, remember my name. Now this will be sent as an input to the user. This will be sent as the user input to the chatbot, and then along with the config details. Because why I'm saying config detail is because I'm referencing the thread ID, which is 1. Okay, again I'm using the same thread ID, which is 1, and I'm asking remember my name. So it is pointing to the same conversation, thread ID as 1, and understanding does the chatbot remembers what it said earlier. Okay, so you are just giving the input as remember my name, and you have this config, and once you run this, so remember my name is your user input, and the chatbot responds with yes, your name is Will. So the chatbot is able to remember what was your name in the previous conversation which you have mentioned. Now what will happen, right? If you have some configurable thread ID is equal to 2, and if you ask again, okay, the user input, remember my name, okay, what it will say? Let us understand that. So this is the user input, okay, remember my name is the human message that you send. The AI sends or the LLM responds with, I do not have access to any personally identifiable information about you. I don't have memory of the past conversation, because it is the new thread that you have created with the ID 2. So the chatbot is not able to recover our previous conversation, get the previous conversation. And what is the next state? What is the state of the chatbot now? Now if you say this is the current state snapshot, and what will be the next state? It should be empty, because it has ended the conversation. There is nothing to follow up with. So this is how memory works in chatbot in LangGraph. So with this I'll be concluding this video. Okay, I hope you understood how to build a chatbot with let me just go back here. Okay, chatbot with an LLM, where you interact with the LLM and get the response. Next, you add a tool to respond to a query which is not handled by the LLM. Then you add a memory to keeping track of thread based on the thread ID. And then you interrupt a conversation with the help of for human in the loop in the chatbot. Okay, so with this I'll conclude this video. Thank you for watching.